So at this point in atomic history, the electron has been discovered, and it's known that it's a very small particle. It's a particle that is within an atom, so a subatomic particle. It's also known that this particle has a negative charge. But just how much negative is this charge? That is what Robert Millikan and his laboratory decided they wanted to determine. So they set up an experiment to determine the charge of an electron. And the experiment that they set up was a pretty famous experiment called the oil drop experiment. So I'll show you all the little pieces of their apparatus and explain how they used it to determine the charge of an electron. It starts off with an atomizer. This is basically just a little perfume bottle that sprays a fine mist of oil droplets in the chamber. So once this is sprayed, these oil droplets are flying everywhere. They're super, super tiny and just minuscule, and they're floating, and they're eventually going to fall down due to gravity and hit this plate. Now within this charged metal plate, that's the red thing on the image there, there's a tiny little hole, and it's a big enough hole where one or two oil droplets can go through. So their goal was to try to get one of these oil droplets. And when they got one of the oil droplets to go through the hole, they would look at it through a microscope that was all lined up. They would ionize the air around this oil droplet, which would cause electrons to stick to it. Now, they can't actually see the electrons, which is interesting, but they can do something because they know that these electrons have a negative charge. So they ionized the air around the oil droplets, causing electrons to stick or jump onto the oil droplets. That's going to cause the oil droplet to have a negative charge because there are electrons on it. Now notice how we have two charged plates. We have a positive charge plate and a negative charge plate. Now the scientists doing this experiment had a dial so they could indicate how strong the charge would be. Now remember, negatives repel negatives. Don't forget that. So what they did when they were experimenting is they had this charged particle with a bunch of electrons on it. They don't know how many electrons falling through this hole. And what they're going to do is they're going to turn on the charge of these plates. And that will cause this negatively charged oil droplet to move toward the positive plate. Now, naturally, it will want to move down. If gravity had its way and the charged plates were off, yes, this oil droplet would want to fall. But as we increase the electricity, the droplet will stop falling and actually float upward toward the positively charged plate. So I'm drawing an eyeball here, and they could see through the microscope, see this droplet stop falling and move toward the positively charged plate as they increase the electricity because opposites attract. Now I'm going to give you some sample numbers here. Say the first time they did this experiment. They had a droplet and their electricity dial had to be set at 1.60 times 10 to the negative 19th coulombs. The next time they did the experiment, we'll say that their dial had to be set to 8.00 times 10 to the negative 19th coulombs. Now what their goal is to get the droplet to hover. So they had to adjust their dial different amounts depending on how many electrons jumped onto the oil droplet. Remember, they can't count the electrons. They can't see the electrons. So each time they did the experiment, I'm giving you sample sets of data here. Each time they did the experiment, they got different amounts that they had to adjust the dial to get that little oil droplet to hover because every oil droplet was slightly different than the previous one. So these are 6 possible data points that they got. And all 6 of these numbers have something in common. So take a look at these 6 numbers, determine what they have in common. They have one thing in common. The commonality with these 6 numbers is they are all divisible, perfectly divisible by 1.60 times 10 to the negative 19th. Remember, Millikan did not know how many electrons jumped onto the oil droplet. All he knew is he needed a different amount of electricity to make each of those oil droplets hover. So 1.60 times 10 to the negative 19th goes into itself one time. It goes into 8.00 times 10 to the negative 19th 5 times. It goes into 4.0 times 10 to the negative 19th 3 times. It goes into 6.40 times 10 to the negative 19th 4 times. It goes into the next number 2 times, and then the last number 6 times. So these are all even numbers, even amounts. It turns out that that number is the number of electrons that jumped onto the oil droplet. It had to be. There was no in-between amounts. And electrons are either there or they're not there. So that number, it turns out that it is the number of electrons that jumped onto the oil droplet. And that tells us something very important. If we have one electron on that oil droplet, it will have a charge, or will give that oil droplet a charge of 1.60 times 10 to the negative 19th coulombs. That is the charge of an electron, and that's how Millikan and his lab group determined the charge of that electron.